Hi everyone, it's me, Carolyn, and we're going to be talking about hypotheses testing still in this video, but we're going to be looking at hypotheses tests for the population mean. So it's going to be very similar to some of the things we've seen with the confidence intervals. So we'll be using our t-distribution and so forth. So I'm going to jump into my guided notes and we'll go from there. All right. So we are, like I said, we are in chapter 10. This is section 10.3, and we are going to be doing some hypotheses tests for the population mean. So there are some things that we do need to check in order to make sure that we can use the tables that we do. There are processes out there if these checks don't work. But they are a lot more sophisticated than we are ever going to need to deal with. Again, this class just gives a rough introduction to things. So the first thing you're going to want to check is that you have a large sample. Again, the magic number tends to be anything bigger than 30 is large enough. We also kind of want to make sure there's no outliers. So a lot of times what will be done, we won't worry too much about that. And do like we did for outliers before. And again, if the samples are small, we would kind of look to see if they're somewhat normal. Again, the only one that we're really going to check is the first one, because we do not have the tools to do something if they aren't. So again, we are just doing a brief introduction to statistics. If you want to continue with statistics, there's lots of courses at four-year universities out there. So these, first of all, we're going to have our 5 steps. Again, some places do 6 steps. We will do the 5 steps. They're going to be very similar to the ones we saw for the hypotheses test for the proportion, except we will be using a different test statistic. So again, the first step is to determine that null and alternative hypothesis. So we will actually be writing those out. The next one is going to be getting that level of significance, that alpha level, that will be given for us in the problems. And a lot of times, again, that is like 0.05 or 0.01, based on how life involvement is. It's probably not stated very correctly, but step 3 is to compute that test statistic. This is a t-value as long as our sample is large enough. And we will have this x bar minus our mu 0 and our s, which is again that sample standard deviation, and the square root of our n. So we've seen these pieces before, so it's not a whole lot of new stuff. And then step 4 is depends on which method you want to go through. We either find our critical values, which are based on the alpha, or we find our p-value, which is based on our test statistic. With technology that we have out there, finding the p-value is a lot easier in today's world than it was 5-6 years ago when we had tables. When we only had tables at our disposal, the critical values were the ones that we used. But with technology, we're starting to see a shift leaning towards finding that p-value. And then we're going to make a decision based to reject the null or not reject, and then we write that conclusion. Again, if there were 6 steps, they break this into 2. One is to reject or not reject, and then step 6 would be to write that conclusion. Our author has decided to put those 2 steps together. I do have us going through 3 examples. And I will be going through the first one completely by hand. When I get to the next 2, I will be using some technology to help speed things up. I will write out our test statistic as far as the formula goes, but again, I will go to Excel, not Excel, what am I talking about? I will go to StatCrunch and get that value. But this first one, I'm going to go through all of the pieces by hand using the tables and so forth, but I will also then verify it with StatCrunch. The second 2, I will use StatCrunch only to get my information. Okay, so here we have that the mean height of American males is 176.3. The height of the 44 male presidents has a mean of 180.1, standard deviation of 7.1, and we're going to treat those 44 presidents as a random sample. And we want to know, is there enough evidence to suggest that the presidents are taller than the typical US male? Okay, so we're going to go through our 5 steps. Step number 1 is to write those hypotheses. And we use H with the 0 and H with the 1. Again, some textbooks will use an A instead of a 1. And we are testing about the mean. So that means we're looking at mu. So that's our parameter that it's going to be in our hypotheses. And you do want to make sure to put the parameter that you're measuring or testing in these statements. In our last examples, they were P for proportion. We can do tests on the standard deviation. So we could see a sigma in here. In this course, we will not get to that point. So we are trying to find out if they are taller. So again, the status quo is the height of males. So that's the 176.3. So we're looking at, are the men or our presidents taller? So that would be bigger than that 176.3. So there's our step 1. Step 2 is to find that alpha level, and that is already determined for us in the problem. So I'm just going to write it down to 0.05. I have one that points on it. It's kind of crazy. 0.05, that was a typo there. And now step 3 is our test statistic. So T, because we do have more than 30, so we are able to use our T curve. So T, again, the formula is our X bar minus mu0 over S over the square root of N. Okay, now our X bar, that's the sample that we took. That was our 180.1 for our presidents. The mu0 is the number of the status quo. So that's kind of at 176.3. S is the standard deviation of our sample. And N is the sample size, which in this case was 44. Okay, so I'm going to get out my calculator and do this math. I'm taking 100, subtracting off 176.3, getting that value. I'm going to divide that by 7.1 divided by that square root of 44, making sure that this piece is completely in parentheses. So you want to make sure we get that value. And I come up with 3.55018 ... There's more digits there if you want them. So we get, but that's far enough. Okay, so that is our test statistic. Now, step 4 is where we do one. And that's where we find our critical values, or we find our p-value. Okay, so the critical values, those are based on alpha. P-value is going to be again based on that p, which we just found to be 3.5. Okay, now we are looking for a t value, so I'm dragging out my t table that I have. Okay, and we have our, so I'm going to do the critical values first. Notice that we are going up, so this is a one directional tail, and we're going greater, so we're looking at this end here. So in this case, this is where our alpha is. And so we're looking at an alpha of 0.05. And again, sorry for that typo. And again, remembering that when we're dealing with the T curve, we have degrees of freedom. So our degrees of freedom would be that 44 minus our 1, which would be 43. Okay, so we're going to go down. First of all, I'm going to find my 0.05. 5 is across the top. And I'm going to go down to 43. Well, we don't have 43 on the table that I have, or the table that was provided by our textbook. So I'm going to err on being a little bit cautious and have my critical value being 40, which is 1.684. So my critical value is 1.684 because I used n equaling 40. Okay, so if I'm looking at my picture, there's 0.05. This is the number 1.684. Okay, if I were finding p-values, what we're trying to find is, here's my p, which is the 3.55. I'm trying to find the probability. So this is the p-value that I'm looking for. Okay, so this works a little bit differently. We still have our degrees of freedom of being our 44 minus 1, which is 43. So what we have to do is we're going to kind of go backwards. So I'm looking, and again, we don't have 43, so I'm going to be looking at 40. And I'm going to be looking for this 3.55 along these values. So these are like the t values. And if I'm kind of skimming, I'm kind of looking for 3.55, but I'm not finding it. But I see that it's between, oh, it's like a 3.307 and a 3.3551. So my T is between these two. Okay, I'll write that down here. My T is between that last one here, that 3.307 and that 3.551, which corresponded, if I go up to the top, to a probability of 0.001 and 0.0005. So pick those values up to the top. Okay, so I took my two values that it was bounding. So my p-value is somewhere between those two. So the p-value is between these two. And this is how you would do it using a table. You wouldn't be able to necessarily find the p-value for a t. We can for the z, because that gave us a z value, and we could find the probability for that z value. But t is a little bit different. We can only get it between two, unless we happen to find it right on the table. So it's going to be smaller than this guy, but bigger than this one. So our p-value is somewhere in here. Okay. And there is step 4. We would do one or the other. Now, if we were using tables, I would tend to find my critical value. Finding a p-value is a little bit more difficult. If I'm using technology, both of them are relatively easy to do. Okay. Step 5 is to make our decision and to then again write our conclusion. Okay. And the way we make our decision, I'm going to get a different color here, is we were using our critical values. What we do is we then look at where did our test statistic fall in that piece. So if we look at our picture, here's that 0.05. Here's that 1.684 critical value. Our 3.55 is here. So it's inside that critical region, or I like to call it the rejection region. It's far enough away from the 0 to say that, yes, we are going to reject. But we will reject because it's in that rejection region. If I'm doing a p-value, now notice our p-value is very, very small. So when we do it using the p-value, we can we look to see, is our p-value smaller than alpha? our p-value is here. The alpha we're looking at is 0.05. This is quite a bit smaller than 0.05, so we would reject as well. There will not be a time where you would reject one way and not reject the other way. These are just two different methods of getting to that same conclusion. Okay, so we are going to reject the null, meaning that we kind of agree with this piece here. So our conclusion would be that there is enough evidence to show that the presidents are taller than the typical male, American male. Sorry, I'll put that in there. Okay, and writing my conclusions here on the spot are probably not as polished as they could be if I rewrote them. So there's enough evidence to suggest or to show that U.S. presidents are taller. That might on here, taller than the typical American male. All right, let's do another one. But before I do that, let's go and do StatCrunch to kind of show that, yes, we do get those same values. So I'm going to switch screens here and look at StatCrunch. Okay, so I'm here at StatCrunch, and we're going to be testing, again, it's under our statistics. We are going to be doing a t-statistic. We are doing one sample because we're looking at one data set. We didn't have the original data, although you could have the original data. So if we had, instead of having the actual mean of the 44 presidents, we actually had their original heights, we would find, first of all, the mean and the standard deviation. So sometimes you may have to do that single extra step. But we were given the summary. Our sample mean was that 180.1. Whoops, 0.1. Our sample standard deviation they gave us was 7.1. Again, you may have to find those values. 7.1. Our sample size, we had 44 people. We are doing a hypotheses test, and we are testing that against the 176.3, and we are doing a strict greater than. Let's find our critical values. Again, significant level of 0.05. And we will compute. All right, so there's our sample mean, some standard error, degrees of freedom. That was the 43 that we had. Our test statistics was at 3.55. That is what I had gotten. Our critical value, we had 1.684. This one is slightly more accurate because ours was based on a degrees of freedom of 40. They are actually able to get to 43. And the p-value they have is 0.0005. If you remember, for 40, that 0.0005 was a 3.551. So if we'd gone down a little bit, we may have been able to see that, yes, at 43, it was that 3.550, whatever you get. So we do get the same values that we did before. Okay, and I'm going to use StatCrunch here for the next ones, just to speed things up a little bit as far as looking on the tables. I'm going to kind of come here and get my critical values or my p-value and kind of work that way. All right, so I'm going to go back to my notes so we can get to that next example here. Oops, sorry. Got to click the button. All right, let's see, what do we got? The mean temperature of humans is 98.6. Researchers thought the mean temperature of humans is less than that. And so what they did is they went out and they took a sample of 70 measurements, and they found that the average of those 70 people, or 70, what I'm assuming 70 people, to be 98.2. They had a standard deviation of 0.7, and we're going to find out if the mean temperature is less than that at alpha equal to 0.01. All right, so I'm going to be going through my steps. Again, when it comes to steps 3 and 4, I will probably go to StatCrunch a little bit to get those values, but we will do all the other steps here by hand. So step 1, first of all, and there really isn't any technology that does this step for us, because this is the part where the humans have to decide what they're testing. So technology can't do that for us yet. I'm guessing it's coming with AI, but a lot of times we still want to kind of have some control over what we're doing. All right, so we are testing the mean. So again, that is mu. And we always kind of test it equal versus something. And we have that standard. People think that it is 98.6. And they think it is less than that. So we're going to go smaller than 98.6. Step 2 is to find that alpha level or point it out. We have an alpha of 0.01 because we don't want to go and rewrite all the medical handbooks unless we have to. Step 3 is our test statistic. Since we did 70 measurements, that is greater than the 30, and we should write that down or verify that fact. I'm doing that verbally here in the lecture. So we are able to use our t, which is x bar minus mu 0 over s square root of n. Bar the 98.6. Divide that by 0.7 over that square root of 70. And again, I'm going to go to StatCrunch to get that piece. I'm also going to go to StatCrunch to get my 2 pieces. I'm going to get my critical value and my p-value. And then we'll do steps 5 and 6 after that. So I'm going to go into StatCrunch. And we are going to do a new test. So I'll get rid of this guy. And we're going into stats again. This is a t statistic because we are, and we have 1 sample. Again, we have the summary. We have the actual sample mean, which was a 98.2. Our sample standard deviation was 0.7. Is that what we have? 0.7. Sample size was 70. We are testing 98.6 versus smaller. Okay, I want to show my critical values, and here my alpha we decided was 0.01 because it is kind of important before we go rewriting all of the textbooks. We want to make sure we can have enough proof or enough evidence that we should rewrite everything. And here come our results. Okay, so our test statistics, which is step number 3, is kind of shown right here. This guy right here, that t-stat, that would have been a negative 4.7809. Our critical value is a negative 2.38. And our p-value is smaller than 0.0001. So I've kind of written those pieces down. I did just round that to 2 digits. You can, of course, use more. But we'll now go back to our notes. I have all those numbers written down from our results. Okay, so then we can just do our decision. So here was our test statistic, that t-stat. Here was our critical value based on the 0.01, and here's our p-value. So drawing some pictures, okay, so we can make our decisions. This is a t-curve, not a normal curve, but again, they are both bell-shaped-ish. We are doing this time, again, a one tail because we're going smaller. So I'm putting my alpha in here, so that's my 0.01. And my critical value, that's this value right here, is at negative 2.38. And this picture we have test statistic itself. And the probability, or that area of the tail that goes with it, is smaller than 0.001. Smaller than. Okay, so to make our decisions, if we're using a critical value, we're going to put that test statistic in here somewhere. So if it was, it's going to be on this side because remember they're centered at 0. This is going to be where that point negative 4.78 is located. It is in that rejection region. Here we kind of look at our p-value and we compare to alpha. We want to know, is it smaller than alpha? Our alpha is 0.01, less than that. So this is, it's less than that. Either case, we are going to reject H naught. Okay. And I mean, as a statistician, we understand that. As someone who's reading some publications, you would want to know, well, what does that mean? Well, this means there is enough or significant evidence to show that the average, we're going to go back to our temperature for a human is less than 0.6. And since we've shown that here in this example, we probably want to verify it. They'd probably do another sample, make sure they do still get those same results. I don't know how many samples they would do before they start saying, okay, we need a new number to represent the average temperature of humans. But that's what they would go and do. And then rewrite all the medical textbooks and everything out there. And say average is 98.6. All right, one more. You can kind of guess. Again, we'll use StatCrunch to speed things up a little bit. But we've done an upper tail or a right tail. We've done a lower tail, a left tail. This one is going to be going both directions. So this is going to be a two-tail. All right, we have in 2002, the average household expenditure for energy was $14.93 per year. I did not make these numbers up, or I did make these numbers up. These are not necessarily true numbers in any of my examples. I just steal these things from textbooks, and I don't know if their information is correct. So do not take my examples for truth. Okay. Like the last one, those 70 people, that was just arbitrary information. All right, so again, average expenditure of energy, $14.93. Economist wants to know if this has changed, okay, because obviously it's no longer 2002. So they take a random sample of 35 households, and they found there, it should have been there, or she found the average amount to be 1618, standard deviation of 321. And we're going to test this at 0.05. So again, we're going to write all of our steps. So step 1 is our hypotheses. Hopefully you are starting to understand that how to write these things. We are talking about the mean, the average. So that is our mu. in 2002, so we're going to be basing it on an old piece of information. And we want to know if it has changed. So changing just means not equal to. We aren't trying to find out if it's gone up or if it's gone down. We just want to know if it has changed. Step 2 is that alpha level, so I'm pulling that out of our problem. Step 3 is our test statistic, which is a T. We did grab 35 houses, which is more than the 30, so we are able to proceed. So that again is our X bar minus our mu 0, S over the square root of n. X bar for our sample was the 16. 14 was the one in the hypotheses. S is at 321. And our square root of n ending the 35 houses. And I will go to StatCrunch to grab that. And I will get our critical values. I'm going to abbreviate a little bit here. And our p-value. And again, you do not need to do both of these if you're doing a test. One of these methods is okay. You do but some people prefer one over the other. And it just kind of depends on, I don't know, I guess it's the technology that you're using or the tables that you're using or what you're using to get your information. Okay. But with technology nowadays, a lot of people, I said, are leaning towards getting those p-values. All right, so we're doing a t-statistic, one sample with summary, because we do not have the original data. Our sample mean was at 1680. 1618, sorry. Our sample standard deviation is that 321, kind of a large standard deviation, so we're spread out all over the place, which could cause some issues. And then our S is that 35, sample size is 35. We are testing not against 0, but against that 1493. And we are doing a not equal to. Okay, I do want my critical values. Our alpha level for this problem was 0.01. And compute. All right, so from here, we have our sample mean, our error, degrees of freedom is 34. So if we were looking on tables, we'd be looking at 34. Our t-stat is 2.303. I should probably say 2.304. If I round to 3 digits. Critical value is 2.728. Our p-value 0.0275. Okay, so I've got my information going back to my notes. So I can make my decisions and write my conclusion. All right, so there is my test statistics, my critical values, and my p-value. All right, so if I were using critical values, draw my little picture. Okay, we are doing a not equal to. So really, we're going both directions. So we actually have 2 critical values. We have the negative 2.728 and our positive 2.728. Okay, and now we're going to take our critical value, our test value, and put it into our picture. So our 2.3 is sitting somewhere here, 2.304. So notice it is not in these tails like the last 2 have been. It's not in there. So we will not reject H naught. I'm looking here, my p-value is 0.02. Our alpha level is 0.01. We always say, is it less than? It is not less than. That's not true. So we will not reject. Okay. Not rejecting means that there is not enough evidence to show a change in the, what were we measuring? In the average energy costs. Energy costs from 2000. And my guess is it's because there was such a large standard deviation. Yes, our 1618 was higher, but it wasn't high enough, a big enough change. Okay. One thing to kind of keep in mind as well, when you are doing a two-tail test, you can also kind of look at our confidence interval to kind of reaffirm that piece. So I did kind of write this out here. If we remember our two-tail, we can kind of look at that confidence interval. So our confidence interval looked something like this. Okay, but again, we can use StatCrunch to do all the work for us. So I'm going to go back into StatCrunch and actually calculate that piece. But I'm going to put our numbers in here just to kind of remind us how we did this. So our X bar, that was our 1618 that we had. Plus or minus our T alpha over 2. Now our alpha was 0.01. So alpha over 2 is going to be 0.005. And if I go to my table, okay, I'm going to kind of go to my table. Remember, degrees of freedom is M. So 35 minus 1. I'm looking at 0.5 going down to 34. And that's 2.728. 2.728, which was also, no surprise here, the critical value for our test. Okay, that is the exact same place that they get those. Our S was that 321 over the square root of 35. So you could crank these values out, get your upper and lower bounds. I am going to go to StatCrunch to do it for me to save myself some time. And also to remind you how to do it in StatCrunch. So I'll get rid of this. Okay, so again, we go into statistics. This is a T statistic for one sample. We do a summary. So it's the same as if you were doing this before. So again, we're going to be typing in our sample mean, which was our 1618, our standard deviation, which is the 321, our sample size, which was 35. Okay, but we're not doing a hypothesis test. We're doing a confidence level. Our alpha is 0.01. So that means we're doing a 99%. Remembering 99 and the 0.01 is on the tails. So we're 1 minus alpha. So we can now compute that. Okay, and I'm going to write these numbers down. So our lower bound is 11469.96, and our upper bound, I'm writing these on my paper, 1766.04. I just rounded 2 digits. There's your lower bound and your upper bound. Notice degrees of freedom. And going back to my notes one last time. Okay, so I have my pieces here. There was our formula, the lower bound, our upper bound. And if you look at our value, that 1493 is in this interval. Our 1493 is in the interval. So it's kind of, because it's bigger than this one, but less than that one. So it's in there. It's between those two numbers. So we would not reject. To reject that value that's in your hypotheses cannot be in your interval, because your interval has to be completely not containing it. Because if you think about it, when we found confidence intervals, okay, we are now, this one here is, we're 99% confident that the true average spent on energy is between these two values. Well, and that 1493 is still inside there. So it's there. So 99%, you know, we can't reject. Okay, I am going to stop sharing and come back to just me, kind of wrap up this video. If I can get my mouse to work today. I'm having lots of technical issues here. Come on. There we go. That kind of concludes our discussion on chapter 10. We just, again, touched on hypotheses testing for the population proportion. That was 10.2 and 10.3, which is just on the mean. We are going to be moving into chapter 11, which is going to be comparing not just one sample to a number, but comparing two different samples. So looking at a group of men and a group of women, or a group from 2002, getting that information compared to a group from now. So not just having the number from 2000 and assuming that that's it, but actually looking at different samples from each of those eras and how we deal with that. So that's going to be chapter 11, is looking at two samples. So you'll remember when we went to in StatCrunch, we went to our t-test, one sample. We'll be going to that two sample, or we'll be going to a z-test, one sample or two samples, or proportions, depending on what we're measuring. Again, you can do hypotheses testing on other parameters. We are just touching the surface and looking at just a couple. But again, I will see all of you in the next video. Have a great day.